Welcome to EDU World Space.
Here we're given another solid of revolution, where again this surface here is defined by y squared plus z squared equals kx. So we grow the radius, and basically this is just the radius, right? So this is the radius squared, I mean. So y squared plus z squared is the radius in the yz plane. And so we'll use polar coordinates with our x as our height. And so we can write this in terms of a function. So the radius of this thing here is the radius squared is kx, and that's a function of x. Now we can figure out that k equals a squared over h just by knowing that the radius is a when x equals h. And so we have R1, this function that describes the surface here is R1 equals a square root of x over h. Now we want the mass moment about the y-axis here. So that is the integral over the volume of the density times x squared plus z squared. And so x squared we can leave alone, but z squared, again, if we take, if this is theta here, we can say that z equals r cosine of theta, and substitute that in and get get our differential volume element in polar coordinates is r dr dx d theta. R is integrated from 0 to r1. Okay, so again, whatever the radius is as a function of x. Then we need to go from, x goes from 0 to h, and theta goes from 0 to 2 pi. We can then crank through all of the calculus here, and after a while we get that this becomes rho over 12 a squared h times the quantity a squared plus 3h squared all times pi. Now we can calculate the volume by substituting in here just 1. And the volume of this thing turns out to be pi over 2a squared times h. And so the density is just the mass times the volume. So if we substitute back, we get that the mass moment about the y-axis is m over 6 times a squared plus 3h squared. They also wanted us to calculate the radius of gyration, which for the masses, we have the mass moment divided by the mass instead of the area moment divided by the area, and so the square root of that, and this time we get 1/6 a squared plus 3h squared, and the square root of that whole thing.